Hi, everybody. Welcome back to the Shuko Statistic Lecturing Series. And today, this video, we are still in the unit of random variables and distributions. And so this video, we're going to expand the idea from the one single random variable. Then we're going to talk about how about if you have more than one random variable. So then what will be the probability distribution function and what will be the joint the distribution function. So what will be like if you have more than one random variable. So if you have 2 or 3, what is the joint probability distribution and what is the joint CDF? So we're going to divide just like before. We're going to talk about the discrete first, then we're going to talk about the continuous, right? So still refresh the memory. What is we call the discrete, like if you have a table form for the X random variable value associated with probability, we call this is a probability distribution, right? Then the cumulative one, we call this a distribution function, it's the CDF. So now let's take a look at how do we do it if we have more than one random variable. So I'm going to start with the 2 random variables. So if you know how the 2 random variables, then you can expand it easily. The concept and method, they are exactly the same. You just expand it from 2 to 3, 3 to 4, right? Okay, so now let's take a look at the definition. Okay, about what we call this, the joint probability distributions here. So take a look at the joint distribution. So like I mentioned before here, right? So we are talking about the 2. So if X and Y are discrete random variables here, then the joint probability distribution is, that's what we defined, is f of xy is equal to, then the random variable x equal to a value and the random variable y equal to a value. So each pair of the xy, I have a value of here. So if you kind of remember, let's review, okay. This is a 4. Misspelling. So like for the one random variables here, right? So one random variable, so we talk about is this one, the tabular forms, right? So we say this is x, this is f of x. So x could be some values, and then this is the probability. So the probability could be some different values here, right? So this is for one random variable. So now if for 2 random variables, so it's the same way. So that means for each pair of x, y, you have a probability. So it will be something like this instead of a table. So this is x, this is y. So the x, you have some values here. Then y, you have some values here, right? And then for each one, you have the associated probability. Okay, so that is what we call is the probability distribution. Okay, so this is what we call is a joint probability distribution for the discrete, right? So that means each pair going to have one value. And also for a single variable, we say we have 2 very important properties here, right? So what are the important properties if you still remember for single variable? So we say the f of x has to be greater than or equal to 0. So here, right, so the probability here has to be greater than or equal to 0. You cannot have negative probability. Then we also say if you add all this together, what is going to happen? It's going to be 1, right? Because when you add them together, that means you add every possible outcome for your sample space. It's going to be 1. So then the next theory, now we expand to the 2 variables, the joint probability distribution. So they still have the same properties here. So that means the f of x, y, that means every single values here, right? The joint distributions here. Every single values here has to be what? It's greater than 0, greater than or equal to 0. That means we cannot have negative probability. Then the next things here is the same. For the one random variable, when you add all them together, is 1. So for the two random variables, so it's the same things here. So when you add all the x, y values together, so for these ones here, if you add all this together, what you're going to have, you're going to be 1s, right? So that's why I said when we did the single variable, I say it's very, very important, because if you still not quite familiar with the one single variable, now we expand it to the joint probability distribution for the more than one random variables, then you're going to have a trouble. But if you get a pretty good solid foundation, now this one is just extensions, right? So everything follows the same way. It's kind of similar, like I remember, when we talk about in the calculus 3, the multivariate, right? So we always refer back to the single variable. So if you know the single variable, you go into the multivariate, work is pretty easy, okay? Okay, so now the next thing here we talk about is a joint, okay? Joint distribution function. That means we also call that the cumulative distribution functions, right? So it's the CDF here, right? So let's take a look here. So if you still remember, for the single variable, right, the single random variable, so we also defined the CDF is a capital F of X. Remember, the capital F of X is always represent the single random variables, right? So now there is a CDF. So this is really is what here we talked before is X, right? That's equal to this value of X here. So basically what you do here, so basically you say, hey, I'm adding all this probability for all the t less than equal to X. That's why we call this is a CDF, right? So that means it's the cumulative distribution function all the way to what? All the way to these X values here. So for the joint, it's the same. So if you give me the X and Y, so the joint just be, the CDF is what? You just add all the X less than equal to X and Y equal to Y, less than equal to Y, right? So basically you need to add both X and Y. Right? Okay, so now if you are clear, so the definition and the theory are kind of pretty similar, like the one random variable. So let's take a look, how do we do some examples here. Okay, so the first one's to here, okay? So let's take a look. So let's say here, two captives are selected random from the bottle, and containing 3 aspirins, 2 sedative, and 4 laxative caplets, okay? X and Y are the number of the aspirins here. Okay, so let's try to highlight here. The X is the number of the aspirin, and the Y is the number of the sedative caplets here, all right? Okay, so that's good. And now, let's take a look here. So let's see. All right. So here they said, so they say here, they say, okay, so now let's try to find the joint probability distributions here. Okay, so let's take a look at the joint distributions. And okay, so like in here, all right, so let me get a color. Which color? I like black. All right. Okay. So now remember, this is X and Y's, right? So I'm going to what? I'm going to have a tables, right? So I'm going to have a tables here. So let's see here. So that means that here this is my. Okay. Then here this is the. My other ones here, let me see here, right? So here, this is, okay, so what is that color called? Okay, that color, okay. Okay, so here, so this is the other one, okay, so here, right? Okay, so this is the X, this is the Y. Okay, so I'm only take 2 caplets here. X is the aspirin, right? So take 2 caplets. So what the possible value of X can be? Can be 0 aspirin, 1 aspirin, and 2 aspirins, right? Okay, so now Y is the sedative, right? The sedatives here could be 0, 1, and 2 also, correct? Okay, so in this box here, so take a look here. If in this box here, I have 3 aspirin, and I have 2 sedative, and 4 laxative. So total, how many I have? Total, I have 9, right? Okay, so now, first I find this table, like we said, this is joint distributions. Now the next thing here, I'm going to find the probability of this, all right? So, and they also like want to find the probability distributions, right? So the here, okay, so let's take a look, how is this one works here, right? So the probabilities here, we say for every single combination, the possible value of xy is here, right? So the xy is here, so think about. So total, how many I'm taking? I'm taking, a total I have 9, right? I want to take 2 caplets. So what is the bottom here? So this will be C to the what? 9, you take 2, correct? Okay, so the 9, you take 2. Then the top here, right? So I'm only take from the aspirin. How many aspirin I have? 3. So this is 3 aspirins, right? How many I take here? X is here, correct? All right. So now, after that, the sedative. How many sedatives I have? Caplets I have? I have 2. And I have Y's here, correct? Okay, so let me erase this one so I have enough space to write it. Okay, so now, you know, whatever the level will be the laxative, right? So that means for the laxative. So how many laxative I take here? It depends, right? Depends on how many aspirin, how many sedative I have. So this will be the 2 minus X minus Y here, correct? Okay, so now let's see what is the value of X. The X could be what? Is 0, 1, 2. And the Y also can be 0, 1, 2, right? But take a look. Can I have a combination, for example, like 1 aspirin and 2 sedative? Can I have that? No, I can't, right? Because they only want us to take how many caplets? 2 caplets. So if an x0, 1, 2, y0, 1, 2, I also have a conditions here. That means x plus y cannot be less than 2, right? So x plus y has to be greater than 0 and less than 2 here, right? Because I cannot have a combination 1, 2 here, right? So immediately I know then this one's here, the probability here is 0. It cannot happen, right? 2, 1 is 0. This one is 0, right? 2, 2. So those 3 places not going to happen because I only have 2 caplets. Okay, let's try to take a look at the 0, zeros here. That means that when x equal to 0, y equal to 0, I'm only going to do couple, then you will be able to do the remaining and check it. So that means I have a 0 what? 0 aspirin and 0 sedative. And then both of the pills from the laxative, right? So based on this equation, I can say this is the 9 over 2, 9 takes 2. So 3 takes 0, 2 takes 0, and then what is here? So here is 4 take what? 4 take 2 here, correct? Right, so now you put it into your calculator, then you will get what? You will get, I put it there, so I will get 1 over 6 here. So this one is 1 over 6, right? So the same way is here, right? So let's see here. Let's try to do one more, right? Okay, so if I want to find the f of what? f of 1 0. So that means I'm trying to find this area, right? This probability. That means 1 aspirin and no sedative. So here the same way. So it's a 9 take 2, the 9 combination of the 2. So aspirin, how many aspirin you have is 3 1. So how many sedative you have is 2 0. Correct? Okay, now how many laxative you have? So you have to have 1. So laxative is what? It's 1 4 combination of the 1. So if you put it into your calculator, you will get this is 1/3 here. Okay, so this is 1/3. Okay, very good. Okay, so now you can do the remaining the same. Let's try to do 1 in here, right? So how about let's try to do f of the 0, 2. That means, okay, so still the bottom is what? 9, 2, 9 combination of the 2. Now the aspirin is what? Aspirin is 0, right? How about your sedative? How many? 2, right? So it's 2, 2. Okay, if sedative is 2, then do you take any laxative? No, so it's 4 of what? 4 of the 0. So if you put this one into your calculator, you will get is 1/36. All right, so this is 1/36 here. So if you do this calculation for every one of them, I already did. So this one will give you 2/9. Okay, so this one will give you 1/6, and then this one give you 1/12. So in order to check to see you get this one correctly or not. So how do you check it? You add them together, right? So when you add all this blue number, what you're supposed to get? You're supposed to get 1, right? Because you add all the simple space together. Okay, so that's it, right? Okay, so no question. This is how do we find the joint probability distribution for the discrete random variable. Okay, let's take a look at the next example. Okay, so they said use the joint probability distribution to find the CDF, right? So this is what, because this is a capital letter, that means I'm trying to find what? Try to find the CDF here, right? Okay, so how do I find the CDF? So, okay, like we defined before, this is 1, 1, correct? Okay, the 1, 1, that means the probability, you have 2 random variables right now, right? So this is the X value, this is the Y values, right? So now you need to say X is less than equal to 1, and like y equal to less than equal to 1 here. So let's see how many combinations we have. So x less than 1, okay, x here less than equal to 1, right? So x could be what? X could be 0 and 1. And the y less than equal to 1, so that means y could be 0 and 1, right? So you find all these combinations here. So what I have, I can have f of the what? 0, 0, right? 0, 0s here. Then plus f of the x still equal to 0, but y equal to 1. Or you can say the x equal to 1, y equal to 0, then plus f of the 1, 1, right? So I know, that's what I know, the x is less than equal to 1 and y equal less than equal to 1, right? So you have at least 4 different combinations. Now let's take a look from the previous. What is f of 0, 0? It's 1/6, right? So you say this is 1/6. Then 0, 1, that is 0, 1, it's 2/9, right? So you add here is 2/9, right? Then the 1, 0, let's take a look, 1, 0. So what is 1, 0? 1/3, right? So, okay, plus 1/3. Then plus 1, 1. What is 1, 1? Let's go back to here. Take a look here. 1, 1 is what? 1, 1 is 1/6 here. Okay, so this one's here is 1/6 here. Okay, and then you can add them together, so you will get this is what? A over what? A over 9 here. Okay, so let's see here, double check and make sure we get all the correct numbers. Here is 1/6, 1/3, okay, 291/6 here. All right, so now I think we got the correct numbers here. So let's take a look at our next problem. Okay, so let's take a look at our next problem here. Okay, so, and when we finish this problem, we're going to stop here because then the next video, we're going to talk about how to find the joint PDF for the two random variables and also how to find the joint CDF for the two continuous random variables here. Okay, let's take a look. So let's say the number 3 is here. This tell you determine the value of the k for the given function is equal to the k equal to the x and the y's, f of x, y equal to the x and the y's here, x equal to the 1, 2, 3, y equal to the 1, 2, 3, and what is the value of k can serve as a joint probability distributions here. Okay, so what is this means here, right? So let's means in here. This is your x, this is your y here. X is what? It's 1, 2, 3, and the y is 1, 2, 3 here, right? Okay, so now let's take a look here, right? So for the x equal to 1, so you put here is 1 times 1, 1, 1. So what is here? This is k, correct? Okay. So x equal to 1, y equal to 2. So 1, 2. So what is here? This is 2k. X equal to 1, y equal to 3. What is here? This is 3k. Okay, now take a look here. When x equal to 2, y equal to 1. So what is here? So this is 2k. When x equal to 2, y equal to 2. So 2 times 2. So what is here? It's 4k. When x equal to 2, y equal to 3, so 2 times 3, what is here is 6k. So when x equal to 3, y equal to 1, so what is here? 3k. Then 3 times 2 is what is 6k. So the last one, when x equal to 3, y equal to 3, so what I have here is 9k here, right? So this is my probabilities here. Then, if this is a probability distribution, what is the property we have? We say, hey, you add all this. So the summation of all this going to be equal to what? Going to be equal to what? Going to be equal to 1, right? Because you add all the probability, just like we did for the one single random variables here. You need to add them up to 1. So now if you add 1k, 2k, 3k, so it's 1, 2, 3, 6, 6, 8, 12, 18, 21, 21, and 27, 36. Okay, good. So you know when you add them all up, it's 36k. So what is this supposed to equal to? Equal to 1. So what is the case here? So case is 1/36. So when the k equal to 1/36, then this functions here, f of x, y, is a what? Is a probability distribution, right? So it's a probability distribution, just like we did for the one single random variable, right? Okay, that's it. That is for the video number 1. So we talk about the joint probability distribution and the joint CDF for the discrete continuous random variables when you have more than one random variable. So, from the same way, you can expand that to have 2 or 3 or 4 random variables. Then, of course, for the 3 or 4, it will be very difficult for you to write into the table forms, right? So that's why you need to use the general definitions for that. Okay, that's it. And it's nice to talk to you about this topic, and looking forward and for the next video, when we talk about joint PDF and the joint CDF for the continuous random variables here. Okay, so that's it for this video. And I will talk to you for the next one. And you have a good day. All right, bye.